avoid sheets, and much more. And once Emit is put onto the International Space Station, it'll join that fleet.
Wow. And I do know that it's not just what we have orbiting the Earth, there's also a lot of research being done on the ground. So when you consider this whole portfolio of climate research that we're doing, how will this help us address climate change?
Well, the more we know about the planet, the more we can use that to provide the local decision makers, stakeholders, and the public about what's happening on Earth.
Awesome. Guys, thank you so much. I appreciate your time.
Thank you.
And EMIT isn't the only experiment inside Dragon that will study Earth's climate. Students from MIT built what you're about to see on the screen here. This is called Beaver Cube, and it's named after the school's mascot, Tim the Beaver. It's a small satellite about the size of a shoebox, and once deployed, it will measure cloud properties, ocean surface temperatures, and ocean color to analyze Earth's climate and weather systems. T-minus about 11 minutes and counting from liftoff of NASA's and SpaceX's 25th commercial resupply services mission to the International Space Station. Let's bring back Shiva now to tell us more about Dragon.
Thanks, Megan. Now, Dragon is capable of transporting people as well as environmentally sensitive cargo to and from Earth orbit, like we are on today's mission. Starting from the top of the nose cone to the bottom of the trunk, it stands about 27 feet tall and is made up of two main sections. The pressurized capsule and the trunk, which is used for unpressurized cargo and supports the spacecraft on ascent and during on-orbit operations. Now, after separating from Falcon 9, Dragon will autonomously make its way to the International Space Station using its navigation sensors and its engines. The capsule has 16 Draco engines, which are used to get the spacecraft from one place to the next. Now, we've got 12 of those service section Dracos near the bottom of the capsule and 4 near the top of the forward bulkhead underneath the nose cone. Those forward bulkhead Dracos are primarily used for high thrust maneuvers like the orbit changes that we'll need to get to station and eventually in about a month to get back home to Earth. Each of those thrusters are capable of generating about 90 pounds of force in the vacuum of space. Now, the service section Dracos are used primarily for pointing and for operations in proximity to the space station. You can actually see them firing here in these clips taken from the International Space Station on various different Dragon missions as they were approaching the orbiting laboratory. And just like those Merlin engines on Falcon, we also reuse the Dragon thrusters, the Draco thrusters, once that spacecraft returns to Earth. Dragon and Falcon continue to remain in good health, and we're ready to support the on-time liftoff around 8:44 p.m. With that, back to you, Megan.
Perfect news, Shiva. That's what we like to hear. And two people very excited about today's launch are right here next to me. We have Claire Green and Benjamin Whitfield, both of Arkansas State University. They actually have an experiment on board and are about to tell us about it. Great to have you here.
Nice to be here.
All right, you're so excited, I love it. So let's take a look at the screen. We have some pictures of when the team was here earlier, a couple of weeks ago, and you guys were prepping your experiment. What are you guys studying?
So we are studying waxworm larvae and their unique ability to break down thin plastics, think plastic bags, into a non-pollutive byproduct. And we're very curious to see if they could still do this process in microgravity or aboard the space station.
Yeah, so we know that this happens on Earth. Why do you want to see if this happens in microgravity?
Well, the application of breaking down plastics is beneficial anywhere. It's a problem that we're learning how to deal with. So if we can learn how to deal with it on Earth and in the space station, then we can extrapolate that to other environments.
Mm-hmm. Why are you guys interested to see how this will react in space? Is it because we as an organization, NASA, we are thinking about going farther than we've ever been before?
That's exactly what it is we are proposing this as a long-term space travel waste management system because plastic is lightweight, it's cost-effective, it's not going anywhere, and we don't want a pollution problem like we've had on Earth.
Yeah, perfect. So I know that this is the first launch for both of you. Why don't we take a look around really quick? So there it is on the launch pad, Falcon 9 and Dragon. Inside Dragon is your experiment. How are you guys feeling?
It is surreal. It is, it feels like a dream, and it's about to be a dream come true, not just for myself and Claire, but for our whole team, for students at Stanford who also have an experiment going up, and for all the students who assisted us in our citizen science.
Perfect. Guys, I cannot wait to see what you discover. Thank you so much for your time, and I hope you enjoyed the launch.
Thank you so much.
And we have another student experiment on board Dragon today. These guys are in college, but we have a high schooler here. You see Celine Coquelar. She won the annual Genes in Space research competition by designing a new method of detecting water contaminants. If successful, her work could be used to test water quality both in space and also remote parts of the Earth. Genes in Space is made possible through Boeing, a startup called Mini PCR that makes equipment for biology research, and the ISS National Lab. All right, we're just under 6 minutes till, oh no, 6:56. I am having a hard time, guys, but we're close to terminal count. So let's bring back Shiva live from SpaceX headquarters in Hawthorne, California, and Daryl here on Florida Space Coast to walk us through the final moments of the countdown. Guys, take it away.
Thanks, Megan. Now, the SpaceX team is not working any significant issues with both Falcon or Dragon at the moment, and the weather, I hope, is continuing to trend well. Like Daryl had mentioned earlier, we're keeping an eye on some clouds and potential precipitation, and we're going to keep our ear out to the loops to make sure we remain go for launch. The range does remain go for launch at this time. Now, at this point, the rocket propellant 1 fuel is completely loaded on the second stage and nearly fully loaded on the first stage. Liquid oxygen loading is underway on both the stages. That'll complete at about T-minus 2 minutes to launch. At this point, we're also loading helium gas into both the stages. Falcon 9 uses that helium as a pressurant to backfill the propellant tanks as we consume that liquid oxygen and RP1 by the Merlin engines during ascent. Helium load began before the broadcast went live, and it'll continue to top up until about a minute and a half before the launch.
To make sure engine startup goes well, SpaceX performs an engine chill. This happened, will happen, has happened at T-minus 7 minutes. Flowed a small amount of the super chilled LOX into the Merlin engine's turbo pumps. And this is done to avoid a thermal shock to the system when that flow of super chilled liquid oxygen hits the prop system. Now, Dragon began its startup sequence at T-minus 35 minutes when it coordinated timing with the Falcon 9. Dragon now currently undergoing vehicle health checks with the next big step just before liftoff when the cargo spacecraft transitions to internal battery power.
Dragon is in terminal count.
And we just heard that call out for Dragon being in terminal count. And the strong back retract, that's perfect timing. That large truss structure next to the vehicle is called the transporter erector or the strong back. And as was called out on the loops, it pulls away from the vehicle in preparation for liftoff. We'll see those clamp arms around the body of the structure will pull away from Falcon 9. Now, in these last few minutes, Falcon 9 is performing a set of final health checks on its primary communications, avionics, and propulsion systems in preparation for liftoff just about 4 minutes away from now. We're also going to continue to hear call-outs throughout that the engines are sufficiently chilled in as we get closer to liftoff. And on our screen right there, you can see those clamp arms beginning to open around the second stage in between some of that cooling of the Florida air around the second stage. And shortly after, we'll see the white truss structure on the right-hand side of the vehicle begin to pull away from Falcon 9. There you can start to see motion of the transporter erector away. It'll recline a bit before we step further into the liftoff.
And coming up in just about a minute, Shiva, checkouts of the second stage thrust vector control actuators. They are underway. This is often referred to as the engine wiggle test. This is when SpaceX moves the thrust nozzles slightly to make sure that the guidance hardware is go for flight. Again, that was a great view of the transporter erector tilting back. SpaceX does the exact same checkouts of the first stage engines, and that happens just seconds before ignition. At the time of launch, 8:44 and 22 seconds p.m. Eastern Time, the International Space Station will be over the Pacific Ocean, 257 statute miles in altitude.
Now we actually heard just about 30 seconds ago that liquid oxygen loading is complete on the first stage. And coming up here, just under 20 seconds, we'll hear a similar call out on the second stage. That will wrap up propellant loading on Falcon 9 in preparation for launch. At this point, Dragon is performing its final health checks to make sure we're ready to go for rendezvous with the space station about 38 hours from now. And I love the shot of the pad. You can see the clouds forming around Falcon 9 from that cooling. There's a call out there for LOX load complete. You can hear or see the water vapor condensing and forming
Dragon
clouds
is in auto idle
around Falcon 9.
Yeah, you sure can. And just a few minutes left in twilight. A little bit of illumination makes it nice. At T-minus 1 minute, Dragon will transition to internal power. Falcon 9 computers will enter startup mode and begin final pre-launch checks, guiding the rocket through the last seconds before liftoff.
On part pour le décollage de CRS-25 dans maintenant 1 minute.
Dragon is in countdown.
Both stages are now pressurizing for launch.
LG is go for Falcon 9, CRS-25 launch.
So range is go, weather is go.
T-minus 30 seconds.
It's a beautiful time of day to watch this launch and be out on the beach.
T-minus 15.
Here we go. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engine ignition. And liftoff. Liftoff of SpaceX's Falcon 9 rocket, launching Dragon on the 25th mission to resupply the International
Allez, c'est parti pour le décollage. C'est parti pour le décollage de CRS-25. La Falcon 9 qui vient à l'instant de décoller du Kennedy Space Center. Pour le moment, tout se passe bien. On va accéder dans très peu de temps dans la zone de Max Q. Donc la zone de pression maximale. Allez. Tout marche correctement pour l'instant. Allez, on vient de franchir à l'instant la zone de Max Q. Salut Tiff. Alors Tiff pour le coup qui est pas avec moi, Tiff qui est occupé à d'autres activités. Alors je vois qu'il y a quelques petites perturbations au réseau, mais bon ça, malheureusement on ne pourra rien y faire. Au pire on fera un rec qu'on fera en short. Allez, on va bientôt arriver à Meko. Donc Meko, ça sera le moment où on va se séparer du premier étage. On peut commencer à voir comme d'habitude la flamme qui commence à s'étendre. Allez. Allez, dans quelques secondes, séparation du premier étage. Séparation du premier étage. Meko, c'est parti. Séparation du premier étage réussie. Eh bien écoutez, pour l'instant là, le lancement de CRS-25, donc à destination de la Station Spatiale Internationale pour une mission de ravitaillement, j'ai envie de vous dire comme d'habitude, se passe parfaitement. On voit le premier étage qui commence à redescendre sur Terre. Pour le moment, c'est un sans faute, comme d'habitude. On va continuer sur la progression. On aura certainement, et on l'espère en tout cas, un retour du booster sur la barge océanique. Allez, pour le moment, tout est parfait. Allez, on peut voir la progression du booster sur votre écran à gauche. Sur la droite, c'est la progression de CRS-25, donc le cargo de ravitaillement pour la station. Bah écoutez, tout se passe correctement pour l'instant. Allez, on est à mi-chemin du booster pour la rentrée dans l'atmosphère. Allez. Dans à peu près 1 à 2 petites minutes, on va assister au retour dans l'atmosphère du booster. Avec la réception comme d'habitude, hein, voilà, sur la barge océanique. C'est vrai que c'est des lancements qui se ressemblent. Mais bon, on peut se satisfaire que pour le moment, c'est un sans faute à chaque fois. On vous rappelle que si la mission devait échouer, tout simplement, ça serait quand même très préjudiciable pour tout l'équipage de la station qui manquerait du coup leur ravitaillement, soit en vivres, soit en équipement informatique, en équipement scientifique, donc qui pourrait contraindre leur mission. Allez, on commence à voir la Terre sur votre gauche. On voit les RCS également pour les derniers petits coups de boost avant la rentrée dans l'atmosphère. On vient, c'est bon, voilà. Nous sommes à 40 km d'altitude. Allez, le booster qui revient tranquillement sur Terre. D'ici quelques secondes, la réception sur la barge océanique. Allez, moins de 10 km pour la réception du booster. Allez, réception dans quelques secondes. Allez, on rallume le booster pour le dernier coup de freinage. Attention. 500 mètres. On commence à voir la flamme du booster arriver. Alors désolé pour les coupures internet, il y a quelques bugs ce soir.
Gives us a little peek at some of the cargo that we're taking in that unpressurized section. You can see the emit payload there on the left.
Allez, on va bientôt arriver au déploiement de CRS-25 dans à peu près 2 petites minutes. Déploiement de CRS-25, la coiffe également.
International Space Station. CRS-25 will be headed to the forward Harmony port on node 2. We're expecting it to arrive on the 16th around 11:20 a.m. Eastern Time. 1 month attached at the international.
J'en profite également, l'impression 3D qui vient de se terminer, vous avez peut-être entendu le bruit au début du direct. Hop, je vous la montre, peut-être que Tiffany là, qui regarde également le direct va la voir. Bah écoute, ça s'est parfaitement imprimé, ça sera le sujet notamment d'une prochaine vidéo sur la chaîne. On va vous montrer tout le processus à partir du moment où on a sélectionné le fichier jusqu'à la création. Pour l'instant de cette médaille, je ne sais pas si vous la reconnaissez, c'était pour l'année dernière, les 60 ans du coup du premier vol de Yuri Gagarin, ça faisait 60 ans. C'était très bons souvenirs, 1961-2021. Donc voilà, maintenant il n'y a plus qu'un petit coup de peinture à faire et il y aura une petite vidéo qui sortira à ce sujet. Allez, on va arriver au déploiement bientôt de CRS-25, encore quelques secondes. Et puis ouais, on va s'attaquer à ça juste après. Allez, moins de 10 secondes avant le déploiement de CRS-25. Attention, on est arrivé au déploiement. Déploiement réussi de CRS-25. Et c'est parti pour la station spatiale internationale. Donc, amarrage demain. Et bien voilà. Tout c'est parfait. Donc voilà, moi en ce qui me concerne, je vais vous laisser là. Je vous laisse du coup avec cette rediffusion. Et puis je vous dis à la prochaine. Et puis comme je vous dis, on va s'attaquer au sujet d'un nouveau thème d'ailleurs sur la chaîne. On va vous parler un petit peu d'impression 3D. Et puis je vous dis à très bientôt, sûrement à demain pour l'amarrage. Bonne soirée à tous, salut.
Nous sommes go pour la mise à feu. H-.